fancy one like that is good. So we're going to do section P4 today, which is still prerequisites. So we're still talking about things we should already know. And in fact, I really felt like I didn't even need to be there in first hour to teach this because it just most of it just comes back to you super easily. Calculate the slope of a line. Yeah, you've been doing that for years. Write an equation for a line using point-slope form. That one, you might need a little reminder on what point-slope form looks like. Write an equation for a line using slope-intercept form. That's always, even in my lowest Algebra 2 classes, if I ask students, what do you remember about lines? Somebody's hand goes up, I remember y equals mx plus b. Yeah, you do. You know, it's how it is. So this one is going to be new. We probably won't get here today. Write an equation for a line using general form. And it's not difficult. It's just a form name that you have not seen before. That's all it is. Graph linear equations in two variables. That'll be Monday. Write an equation for a line that's parallel or perpendicular to another line. That'll be Monday. Apply linear equations to real world situations. The word problems, Monday. That's what we'll have. So now, what we need to do is just remember all the wonderful things that we've learned in algebra up to this far. So students will be able to use the concepts of slope and y-intercept to graph and write linear equations in two variables, so x's and y's. Anything that's a line, the highest power of the x variable is x to the first. So, you know, it's going really a ways back in your memory banks, but we review all of this stuff every year, whether or not it was in geometry or algebra 2, you've seen this again and again. So lines in a plane, slope of a line. What do you remember about slope? Rise over run. That's usually the first thing when I ask about what do you remember about slope. Everybody remembers rise over run. Anything else? In Algebra 1, when I was teaching Algebra 1, I always had a little song to help the students remember what we're going to use slope for. And it's just slope, slope, find the slope, average rate of change. y2 minus y1 over x2 minus x1. And the reason for that whole song is not that I think that people are going to forget that. It's that people are not going to know that slope is average rate of change. And on the MCAs, they never refer to slope as slope. That would make it too easy. They refer to it as average rate of change. So when we see average rate of change this year, it's just asking about slope. That's all it is. Now, we're not even going to write these two down in this class. What we're going to write down is change in y over change in x, because that little triangle symbol is the Greek symbol delta, and it means change. So it looks like a triangle, but it's not. It means change. So when you get to college, it's always just change in y over change in x. You know, we can think of it as rise over run. We can think of it as slope, slope, minus slope, average rate of change. y2 minus y1 over x2 minus x1. Or whatever is helpful to us. But the significance of this is what we're trying to do is get this to notation. You know, math is, a lot of it is about notation and learning the notation. If you take a college class in mathematics, you usually are required to take a class called logic at the same time. And logic teaches you about those symbols and how you can use those to shorten things up. It's kind of a shorthand for math. So we have a drawing here. And it's showing us that what we're trying to figure out is to go from this point to this point, what would you have to do? Well, you'd have to rise by this much, and you'd have a run of this much. And then over there on the side, it says the slope of a non-vertical line can be found from the coordinates of any 2 points of the line. Why are they leaving out vertical lines? What's so different about the slope of a vertical line that they have to put that little thing in there? It's undefined. I was going to say. All right. It's a keyword. I don't know why. It's just one of those things. Hidden. All right. Slope of a line. Well, slope of a line, M, of a non-vertical line through the points x sub 1, y sub 1, and x sub 2, y sub 2 is. First one here, not a big shocker. Rise over run. change in y over change in x. And then the formula that we think through. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Where those sub numbers are just simply telling us, okay, this is the first point, and this is the second point. It gives us a nice order to those. If the line is vertical, x sub 1 equals x sub 2, and the slope is undefined because for vertical lines, you have some number over 0. Because vertical lines don't have a run, and we can't divide by 0, so that's why that's going to be undefined. That's just how it works. Down here it says, well, let's get busy and find the slope of the line through these 2 points. And then we'll sketch a graph of the line. So what we do is we figure out, okay, the y's are going to be my rise, so negative 2 minus 2 over 4 minus a negative 1, and we get negative 4/5, and we label it m, because m is our variable that stands for slope. I know it's m, but we get used to it. You can't use s. I mean, it's just a bad variable, so m is what we have. So there's our slope, just using a really basic formula. And then just remembering that graphing for negative 1, 2, we go left 1 and up 2. And then for 4, 2, we would go to the right 4 and down 2. And the smart word is not on there. Correct. So finding the slope, not supposed to be much of a challenge at this point. So why don't you go ahead and do B, and I'll check in with you and see what you have for the slope of that one. What did you get for the slope of B? 3 over 2? Everybody? I hope so. And then we'll just quick graph that one. Oh no, words! Find the value of x, so the line between the ordered pair x3 and 5, 9 has a slope of 2. Oh, man. Well, those were really hard in geometry. When you took geometry, that was like, well, how on earth are we going to do that? And then in Algebra 2, we touch on it for maybe like 10 minutes in one lesson. But we need to put this together and say, okay, what could we do with the knowledge that these are my 2 ordered pairs and this is a slope of 2? I know how to find slope. You take 9 minus 3 over 5 minus x, and you set it equal to 2. Well, 9 minus 3 is 6. And then there's a lot of different ways to solve this, but the most comfortable one for most people, pop a 1 under there and cross multiply. And that's the easiest way to get this done. So we'd have 2 times the quantity 5 minus x equals 6. 10 minus 2x equals 6. Subtract 10 from both sides. Negative 2x equals negative 4. Divide by negative 2. And it's 2. So now if we went and put the 2 back in there and we calculated this stuff, we would know what we had. That was our first objective. That's a nice little short one. Slope. Give me your 4, 3, 2, 1, 0. How do you feel about calculating slope? Using it to find other information? Yep, usually these are some pretty good numbers for slope or radius. All right, so now, on we go. Point slope form of the equation of a line. Hang on. That's not this one. That's not called point slope formula. What's that one called? Yeah. Here's the deal with that formula. In math, what we do is we have to pick the best formula for the job. That formula is only the best formula if they literally give you the slope and give you the y-intercept. That's the only time we should be using that formula. Y equals mx plus b. A lot of times that's not what they do. A lot of times there's work that's involved in figuring out these P pieces. So if we're in a situation where we know a point and a slope, this is not it. That's not what we want to use. Because we have a formula for a point and a slope, and that's the point slope formula. That's going to be right in this box down here. But it's one of those formulas that you wish there was some kind of mnemonic device to put it all together, because we need to know it. It's a great formula for a lot of things, MCAs, ACTs, and SATs, and tests that you're going to take. And they never give it to you because they assume you've worked with that formula enough and you know that formula. So there it is. And yeah, people over the years, see, you're going to come up with a song for that one. There isn't a nursery rhyme or anything that just fits with that. It's just like you just have to know it. So if we know the coordinates of one point on a line and the slope of the line, then we can find an equation for that line. And that's what we're going to use, the point slope formula. And obviously, we get a point, we get a slope, we'll use this. Not so obvious maybe is what if it's 2 points. But we've done that before. And I have lots of really high numbers on you guys for slope. So bless you. If we have 2 points, we can find the slope like that. And then have a point and a slope, and we can use this formula. So this is the form of an equation of a line that passes through the point x sub 1, y sub 1, and has a slope of m. And like it says, great to use when you have a point and a slope, or you have 2 points on the same line. So down here, it says, let's go ahead and use the point slope formula. And we're going to find an equation for a line that passes through the points that they have here. And I look at this and I say, well, there's a point and there's a slope. This is my go-to formula. Right there. And what I have to remember is x and y don't go anywhere. They are part of the equation. But my job is to find the numbers that should go in for x sub 1, y sub 1, and m. Well, this is x sub 1, this is y sub 1, and this is m. Right there. So this will be y minus 5 equals 3 times the quantity x minus 2. We just put them in the right place. Now, we don't stop, and here's why. As mathematicians, that should drive us bonkers. We should be saying, oh, I got to distribute the 3 and move the 5 over. There's another reason that we make sure we change this into slope-intercept form, and we'll talk about that as we get a little farther today. So what we will do is we will distribute, and we will add 5, and get y equals 3x minus 1. Go ahead and do B. I have confidence. What are you getting? 2x plus 2. There it is. We put the numbers in the right places, let the formula do what we need. And then we get to C. And we have to ask ourselves, would this be a good one for slope-intercept? We don't have the slope, and we don't have the y-intercept. That would not be a good problem for that. And I think, well, the other one is point slope. Oh, wait a minute, I can find the slope. I know how to find that. All right, so m equals 4 minus 8 over negative 1 minus a negative 3. So 4 minus 8 is negative 4. Negative 1 plus 3 is 2. Oh, cool. I get a nice little integer. Negative 2. Now, I know some of you are overachievers and you've already done this problem, but I'm going to pick anyway that I've caught some of you. I want these 3 rows to do this problem using that first point, negative 3, 8. So put negative 3, 8 in along with our slope of negative 2 to see what you get. And these 3 rows, I want you to do negative 1, 4. Let's see what happens. to check and see if you did it right, check in with a chicken wing elbow partner, somebody that's in front of you, behind you, or whatever. These three rows, you're my green answer. Y equals negative 2x plus 2. Everybody got that? Okay. You guys were the blue answer. Y equals negative 2x plus 2. Hang on a second. I think I just had a deja vu moment. They are the same. So here comes a question that'll take you back to your memory banks. How if we start with two different points, do we end up with the exact same equation? Exactly. It's the same line. And here's the thing about slope-intercept form. There's only one slope-intercept form for every line. We call it unique. That's the fancy word for it in math. There's just one way to write an equation of a line in slope-intercept form. Is there just one way to write a line in point-slope form? Well, we just showed we used two different points and we could get the same thing. How many points are on a line? How many points are on a line? Infinite. Everybody in this room could use a different point on this line. But if I said put it into slope-intercept form, everybody would get what's in the green and blue boxes here. We would all have the same answer. Now, that seems like a small thing, but imagine if the back of the book had to have all the answers in point-slope form. It can't do that because it's infinite. So when we put this into slope-intercept form, what we're doing is we're putting it into a form where everybody can get the same answer and they can check their answers in the back of the book. And that's what we want to do. Andrew, I don't think I have your full attention today.
No, we do.
I hope so.
We do.
Go ahead and do D. You can do that. I know you can. You do it on your own. I used the point negative 2, 3. But when we look at that slope-intercept form, whether or not you use 6, 1 or negative 2, 3, we should all have the same answer. And we do not introduce decimals into a problem that came with fractions. Never. If you need to think in terms of decimals, you can do that, but you don't write any steps down in decimals. Fractions are considered perfect. So if the problem comes with fractions, or even if it doesn't come with fractions, we would never change any of this into decimals and put it through here. So we do it fractions as we go through this. Alrighty. Well, that was point slope form for our objective. So 4, 3, 2, 1, 0 be on point slope form. How's everybody feeling? So that formula is going fine. All right. Well, now to the favorite, slope-intercept form. Slope-intercept form of an equation of a line with slope of m and a y-intercept of 0b is that little bugger right there. Y equals mx plus b. We like that one. Because it gives us the ability to quick graph. You know, one of the units that you have in your Algebra 1 book is quick graphs. And it deals with slope-intercept form and standard form. So this says we're going to solve the point-slope form of the equation for y so we can get it in the slope-intercept form for the reasons I talked about earlier. We want to be able to check our answers in the back of the book. And you can't put infinitely many answers in the back of the book. So we change that into that slope-intercept form. So down here it says let's use our slope-intercept form. Write an equation of a line with a slope of 3 that passes through the point -1, 6 using slope-intercept form. And I'm going to do this a little differently than the instructions have it. If I can find m and b very easily and quickly, I'm just going to do y equals mx plus b. So I go to -1, 6. And I hope by using the slope, I'm going to be able to find that y-intercept right away. And then it'll be super easy to write this equation in this line. Where do I go from that point? Use the slope. Up 3 and right 1. So 1, 2, 3, oh, there it is. That's my y-intercept. That's where this is crossing the y-axis. And that is the point 0, 9. So now I know the point 0, 9 is my y-intercept. They flat out told me the slope is 3. Now I can use slope-intercept because I have everything I need. It's going to be y equals what? 3x plus 9. Done. So if we can get that information super easy, then why go through the point slope form? This definitely we could find that intercept right away. And of course, I want to finish this off with just a quick little sketch of where that line is. Well, every once in a while, that thinking doesn't work. So this one says write an equation of a line with a slope of 1/2 that passes through the point 1, 2 using slope-intercept form. 1, 2. Where's that slope of 1/2 telling me to go? Up 1 and right 2? Oh, well, that's going in the wrong direction. Well, you can use slope backwards. So you could say, okay, normally I'll go up 1 and to the right 2. I'm going to go down 1 and left 2. Uh-oh. I don't think if I draw that line, that's going to hit perfectly at a nice integer, is it? So this is when I say, well, I can't use the method I just used on this last one. It's not perfect. Instead, I'm going to go back to y minus y sub 1 equals m times the quantity x minus x sub 1. And see what happens. So this will give me y minus 2 equals 1/2 times the quantity x minus 1. And we would distribute that lovely little 1/2. And we would add 2 to both sides. And 2 is, of course, 4/2. So -1/2 plus -1/2 plus our 4/2 will be 3/2. So this one had a few more fractions. And now I look at it and I think, well, that makes perfect sense. Yeah, it looks like it's kind of halfway between them. If we'd have had rulers, maybe we would have even guessed that our y-intercept was at that 0, 3/2. It's not about guessing. It's about being accurate and precise. So now we know we found it. So down here we have a little box, but I am guessing. Yeah. So here's what I'm going to tell you. I'm going to give you the assignment. Oops. You'll be able to do just about everything, except you'll get to this one part that says write the equations of lines in general form. We didn't cover that yet. So probably take you 2 seconds of looking at our notes and you'll know what it is. But do what you can on that. And again, if you get to the general form stuff, I guess I would prefer that you waited until we talked about it to do the general form. That way nobody learns it wrong. And we have to do a lot of repetition.